This lesson is designed to help you learn how to properly simplify radical expressions, and we're going to try and iron out a couple of the common mistakes that I've seen over the years people make. So, first example I have here is without variables, just numbers to show you the basic idea. 2 plus 4 over 2, and what I've tried to do on the left-hand side is simplify because we have a 2 on the numerator and the denominator. So if I divide those out, 2 divided by 2 is 1. So 1 plus 4 obviously gives me 5. But if you notice on the right-hand side, without simplifying, if we just work through this using proper math, we do 2 plus 4 to get 6, but 6 divided by 2 is 3. So why is it that the answer is 3, but I can get 5 if I try to cancel? Something must be going wrong here. So a place where I see this happen a lot, obviously when we introduce variables, is that students notice, oh, there's an x squared on the numerator, there's an x squared on the denominator, they're common, why don't we just cancel them out? But for the same reason, we end up with something that isn't equal anymore. It's not the right answer. So what can we do so that simplifying will work for us and not against us? Well, I've changed the question here a little bit. 2 times 4 divided by 2 instead. And notice this time, if I cancel the 2's, if I divide 2 divided by 2, what I end up with here as an answer is 4. And if I work through it using basic operations on the right-hand side, 2 times 4 is 8, divided by 2 is 4. So I get 4. I get exactly the same thing no matter what method I use. Now the change here, the important change, is that I canceled, or I simplified this time, between numbers that were linked by multiplication, not addition or subtraction. And that's the key. Simplifying only works if you can link your numbers with multiplication. You can't cancel across an addition or a subtraction sign. So if we look back at the complicated question again, what can I do here to link my numbers using multiplication? Well, that's what factoring is going to do for us. So if I take the x squared minus 9x plus 20, and I factor that using the product sum method, I get x minus 4 times x minus 5. On the denominator, I notice that it's a difference of squares, x squared minus 16, which is also a square, and I can factor that using difference of squares. So I get x minus 4 times x plus 4. And if you notice where the brackets are, now I have things that are linked by multiplication. That's what I want. So the x minus 4, because it's common on the numerator and the denominator, I can divide them out because any number divided by itself is just 1. So that's why they cancel. X minus 4 divided by x minus 4 is 1. So they're gone, leaving me with x minus 5 over x plus 4, which is a great answer, but we do have to make sure anytime we use a fraction that we're checking for what's called restrictions. So the number one rule when you're working with fractions is that you have to make sure the denominator is never going to be equal to 0. So this is being shown here with an example, a concrete example. 16 over 0 has no meaning. It doesn't mean anything. If you think about it, think about what division does. If you have 16 of something and you have to divide that between 0 people, between nobody, how much do you have? Do you have anything? If there's no people, do they get anything? There's nobody to give all 16 things to, so does it exist? It just doesn't make sense. And if you're still not convinced, take out that calculator, do 16 divided by 0, and even your calculator will tell you there's an error happening here, because they know it's not possible. The one thing I want to make sure you do know is that if you do 0 divided by 16, that's okay. The easiest example, I think, is to say, well, if I got 0 to 16 on a test, wouldn't be a good score, but it is a number. It is 0. So that's okay. I can do that. I just can't have the denominator equal to 0. So I go back to my question that we were working with before, and I say, okay, well, if my denominator can't be 0, let's see if there's anything that x could be that would set it equal to 0. So I take the x minus 4 times x plus 4, and I say, okay, well, that's a product of two numbers, x minus 4 times x plus 4. And if two numbers are being multiplied together to give me an answer of 0, that means one of those two numbers actually has to be 0, because 0 times something always is 0. So I take both brackets separately and say, okay, what would make each of those brackets equal to 0? So I do x minus 4 equals 0, and on the other side of my page I do x plus 4 equals 0 and solve for both x values. So these are the two numbers that I cannot have happen in my question, in my expression, because I know that would set the denominator equal to 0. And if you go back to any point in the question and you test out these numbers, you'll notice that they will make the denominator equal to 0, either here in this step or even in the first step of the question, okay? So test them out, but these are the restrictions. These are the numbers I can't have happen. So in order to give my final answer, I'm going to write the x minus 5 over x plus 4, which was the answer, but I have to say, I add a comma, and I say that x cannot equal those two numbers, the restrictions that we had, positive 4 or negative 4. So I write plus minus 4, and I know that those are my restrictions for this problem. So one little tip I'll leave you with, make sure that you figure out what the restrictions are going to be before you start canceling things out. Because if you start to simplify the expression, you're going to notice you're going to lose some of the restrictions that are actually in the problem. So make sure you do that before you simplify, and you'll be good to go. Good luck, have fun.